Okay, good afternoon and welcome to the Delta Science Brown Bag Seminar, jointly hosted by the Science Program, Ecosystem Restoration Program, and Surface Water Ambient Monitoring Programs. My name is Garrett and I coordinate these events for the Delta Science Program, and I'd like to thank you all for taking the time to physically attend this event or virtually attend at your desktop for those chiming in via WebEx. I'll be passing around a sign-in sheet. So please take a moment just to write your name and your affiliation and email so we can track how many people are attending these events. Bathroom keys are on the shiny brass lures on the wall, and if you need to use the restroom, out the doors to the left and around the corner. Please put the keys back. Don't put them in your pockets. In case of emergency, we're going to calmly proceed out of the room down. My new running joke is we'll follow Sam since he knows where these things are. Thank you. And we will head out the doors, down the elevator, out the doors, and across the street. Down the stairs, we'll follow someone that knows where the stairs are, and we will head out the doors and across the street to Cesar Chavez Plaza. And then most importantly, for everyone on the WebEx, please mute your microphones because to our best efforts, we try to tone you down, but we don't want to hear your conversations or keyboards in the background. And with that, I'm going to pass it off to Reiner for the actual introduction.
All right, thanks, Garrett. My name is Reiner Honicke, and I'm the Deputy EO for Science here at the Stewardship Council. And since I have known Josh for, gosh, going on 25 years, I have the privilege of introducing him. So Josh is the lead scientist at SFEI in the Aquatic Science Center, and he oversees the development of and integration of science done at the Institute. Josh is a landscape ecologist and regional ecological planner with special expertise in mapping and assessing stream and wetland ecosystem health. He received his PhD in entomology from UC Berkeley. One of our independent science board members was his major professor. And Josh is a leader in setting long-range ecological goals, and many of you have had, some of the older ones of you in the room have had interactions with him during the Baylands goal setting process probably 2 decades ago, that now actually recently just led to an update that included climate change projections and adaptations. So Josh has been involved in a variety of advisory roles. Among them, he's the chair of the technical advisory team that helps inform the evolving California wetland and riparian area protection policy, and has been active on many advisory bodies nationally as well. And he is also
Hello?
Hi, I lost audio.
Yeah, same here.
Yeah, same here.
Okay, you guys don't have WebEx set up, so we can't let them know except via email. Somebody got their email open where you can send them a message on the email that was included in the Garrett?
Okay, I think we're there. Okay.
Okay, we're good.
Finally.
And they're going to follow this? Okay, I can probably hit enter. So this is going to be about wetlands, and the word wetlands doesn't even appear in the title. So he can tell you, that gives you an indication of where my head is. I assume you all know what this talk is about, but we're moving towards a comprehensive framework that would begin to coordinate, not integrate. That's a very complicated process, but to coordinate monitoring and assessment for wetlands, riparian areas, and streams through both state and federal government, both on the water quality side, and I hope beginning this year, reaching across and figuring out how coordination across to the habitat site can also happen. And, I've got probably too many slides, so rather than thinking I have to get through them all, which is never the case, If there are questions that are you just really feel as though you have to answer or ask, hopefully getting an answer, go ahead and raise your hand and I'll call on you. I'm seeing a lot of people I haven't seen before, which makes me think maybe for the first time in 3 months, I'll be talking to people about something you haven't seen before. That would be very fun for me. I'm looking forward to that. I'm going to be here for probably an hour or so after the noon hour in case you want to hang around and ask some more questions. Okay, with that, we'll move on. Where's Enter? Okay, good. So there's a starting premise here, which is that both on the clean water side and the endangered species side, both federal and state programs, that many of these programs, essentially all these programs, when it gets to aquatic resources, are taking a watershed or landscape approach to protect the same resources. One of the things we're discovering through comprehensive mapping of aquatic resources, surface waters and related riparian areas, is that we can take the same map to different programs, and those programs will start talking about the things on the map. And as that map gets better, that is, it shows more of the things that different programs want to talk about, we realize they're all talking about the same thing. Now, if you're on the receiving side of that, like if you're going for a permit of some kind to do a project of some kind, you find yourself talking to all those agencies independently, of course, about the same place, about the same resources. So the premise here is that there really is an opportunity, probably a need, to be in coordinating those discussions about similar resources in the same place, both for the sake of government and for the people that government serves. So just to give you some proof of that, here's the addendum to the Federal Register covering habitat conservation planning. Guidelines and principles to achieve biological goals and minimize and mitigate impacts of species or habitat using watershed or landscape approach. This is from 2000. Here's the brand new guidance coming out of the South Pacific Division of the Corps of Engineers. 2014, it was really December 31st of 2014, so it's like just a couple of weeks old. If you've seen that, you know it says, guidelines and principles to achieve biological goals and minimize and mitigate impacts to species or habitat using watershed or landscape approach. Seems pretty similar to me. Maybe not always exactly the same resources, but we get the sense that we're beginning to focus together at the watershed or landscape scale. And there's some reasons for that I won't go into now, but if you stay afterwards, we can talk about what's the big deal about this fourth generation of watershed approach and landscape approach. Why is everybody going there? Probably has something to do with Google Earth. Preliminary draft wetland area protection policy that Ryan referred to. This is the State Water Board's policy. The first draft of that policy covers dredge and fill. That's 401 certification for 404 permits in the Clean Water Act. For some of you, I'm probably speaking gobbledygook, and you would think as a scientist I can't talk this way, but it turns out after 20 years, I can use that kind of policy lingo and almost get out of the room safely. But this is the first stage of the state wetland riparian area protection policy focusing on dredge and fill, and it says that the water boards, the regional water boards, shall use a watershed approach in reviewing compensatory mitigation plans to protect the beneficial uses of state waters. And the rare beneficial use, if you're ever in that world, you know that beneficial uses have names, and those names have definitions, and those are the things that the State Board of Loan Act are supposed to protect. The rare beneficial use means species of special status, wildlife, plants, and animals of special status. So once again, big agencies at the federal level, major agency at the state level, taking a watershed or landscape approach to protect same kinds of things. So here's a key logic coming through the backside of this very cursory review of public policy. But the watershed and landscape approach will improve the cumulative effect of restoration and mitigation, i.e., wow, maybe if we actually plan projects relative to each other in the landscape scale, they'll work better, and we'll know what each other is doing. By the way, if you're ever on the receiving end of the national and regional assessments of how mitigation and restoration is working, you know that a lot of people say it isn't. And part of the reason it's not is that people can't find where the projects are, they can't find the data about the projects, and they can't see the projects together in a landscape setting. Success requires coordination across all projects affecting resource abundance, diversity, and condition. You're going to hear me say this over and over again. Abundance, diversity, and condition. I'm not going to say we did in the 70s, which is functions and values, and I'm not going to say we did in the 80s and the 90s, processes and functions. I'm going to talk about abundance, diversity, and condition. Turns out to be really expensive and very difficult and sometimes equivocal to try to actually measure process and function. Really important to do. I'm not saying you can't do that, you shouldn't do that. I'm a scientist, that's where my heart is, that's where my mind is, where my training is. But when you have to do that for every single project or other activity, you get buried by the data. And so the idea is that there's a certain amount of condition that can be regressed upon process and function. And then you can extrapolate from condition to process and function and then calibrate that extrapolation with the kinds of sincere cause and effect, science that we all want to do. So that's why I'm not saying process and function, not because it doesn't matter, but because we're talking here about a comprehensive framework for assessment. When assessment comes right down to it, it's really hard to assess process and function everywhere. It has to be done in a lot of places, but you can't do it everywhere. Or it would be done everywhere. Coordination requires a common framework and tool set for consistent compliance and effectiveness monitoring. Compliance is basically, as you know, that people do what they said they were going to do, and effectiveness is that it have the effect we want it to have. Two different things, oftentimes requiring different data sets. But you can't separate one from the other. It's not enough just to know, hey, you did what you were supposed to do. The public actually wants to know what the effect of that is. In the 50th anniversary of the Clean Water Act, there was an awful lot written about what has and hasn't happened because of the Clean Water Act. Many national and regional surveys of what the upshot is of all that investment in environmental protection. And the result is mixed, right? But people want to know what they're getting for their investment. Okay, here's the catchphrase. Protect the abundance, diversity, and condition of aquatic resources, that is California and federal surface waters, in a project area equals watershed or other landscape. These are inland waters. Today I'm not going to talk about the ocean. Estuaries, yes. Not excluding all tidal waters, we're not talking about the ocean, not talking about state out the continental shelf, we're talking about inland waters. But this is the idea, protect the abundance, diversity, and condition. So I'm going to go through the framework now. Some of you have probably seen this. This is very elaborate. I'm not going for, memorization of every box and arrow here, kind of complicated, just a gestalt. I'll highlight the things that I think that might be important for you to know going through the rest of this hour. First of all, it's not a program. The Wetland Riparian Area Monitoring Plan framework is not a program. It's a tool set to be implemented through existing programs. Now, it's not a snap to do that. Programs just can't take this thing off the shelf and implement it. There's some accommodation on both sides, and I'll talk about that more later. And the business of transferring to a program or building these tools into a program is a two-way street. The tools never work exactly the way some program person wants them to work. So there's a process there of accommodation on both sides. But the idea is it's not a program with an office like you have here, where you go talk on the ramp guy. It's more like there's going to be these support services for using the tools in existing programs. That's the vision. It's focused on water quality control programs at this time with the prospects to expand the wildlife and habitat prospects. Those conversations haven't really started to happen yet. The idea is that most of this is coming through EPA and the State Water Board and other clean water agencies. It has to be vetted with the regional offices of those agencies in this state before we can really reach across to the habitat people. Because in this state, we've divided the world up into natural resources, more or less, in that part of the world called natural resources, and then water quality over in Cal EPA. And so you start one place, you vet, and then you reach across. We're just getting ready to reach across. In fact, I'm here today as part of a process of beginning to reach across, because some of you in the room are from the habitat side. Thank goodness. I am too, by the way. I started out in landscape ecology and entomology, so I've gone deep into water quality and chemistry. Not a comfortable place for me. After 15 years, I'm emerging from that, looking around for other ecologists. Thank goodness you're out there. So data access and tools vary in development, but progress is being made on many fronts. We haven't just started with one tool, we've started with many tools, and what you're going to see is something that's developed really over the last 20 years. And I can say right now that so far these tools are basically invisible, but they're also indelible. They've already had an effect. They're already changing the way people work. Now we're giving them name, we're pulling them out of the shadows and trying to outreach and get them used more because the people who are using them so far say it would be a good thing to do. So this is not just a new thing. This is stuff that's been around for some time, it's improving, it hasn't plateaued, and it's ready to get out and get used in a broader way. So here's the framework. First of all, start with a regulatory management decision or question. It doesn't say objective. It doesn't say start with the program objective. It says, what decision do you need to make between now or the end of the year, and you don't have all the data you need? This is to inform regulatory management decisions, not just to achieve mission. This is much more pragmatic. And this separates it from a lot of things you've been hearing about, how you can aggregate data at a large scale, everybody can tell their story, very important process. But this isn't that. This is designed to inform particular regulatory management decisions. Haven't identified all those yet. Some have lined up, others might. But this is very pragmatic. It's geared to helping people make a better decision. And it's based upon the information they think they need to do that. And not just them, whoever they is, but the other ones that are doing that too. Because once again, we're back to this program and that program and another program, co-managing, without enough coordination at this time, the same resources in a landscape scale. It turns out that many of these decisions being made by the agencies, all of you and others, for these particular resources, those decisions affect each other, as you can imagine. You know that because you go from office to office to office. Or if you have never applied for a permit to do something in aquatic resources, I challenge you to try. Because you will find yourself going from one agency to another agency at every level of government, trying to keep your nose clean. All right? So this is to help make that happen a little faster. Develop conceptual models of condition and cause and effect. Oh, that's right. It's a science framework. So you have to get people together around these questions, say what data you need, what do we know now, how do they relate to each other? Conceptual models are really important because the people in the room developing those, they own the model. And in this framework, we say, okay, if so-and-so, you really feel strongly about this arrow, you own the arrow. We'll put your name next to it. So it's a way of accounting for what we think we know and we don't know. Very important. You never know everything. But we think there's probably enough known about most things to move forward. So then you identify and classify the data you think you need using the EPA three-tiered system. I'll go through this very quickly. It's a 1, 2, 3 data framework. You've probably heard about this. Level 1 is inventories and metrics based on maps and remote sensing. Level 1 is remote sensing. Level 1 is GIS. Level 1 is everything from maps of roads and habitat to lists of people that attended a meeting. It's that kind of stuff. Level 2 is rapid assessment. You've heard about CRAM maybe, or proper functioning condition. Almost every state of this union, and many nations actually, have rapid assessment methods for streams and riparian zones and wetlands. CRAM is just, it was the latest 8 years ago, and no longer is. I think the latest is probably Puerto Rico's rapid assessment method, which they also call Puerto Rican RAM, so it's P-R-R-A-M, and they pronounce it CRAM. It's wonderful. I know it because I was down there watching it. Level 3 is the intensive assessment of selected aspects of condition. This is the kind of thing that a lot of us were trained to do in science. This is measuring the amount of one thing relative to another. You know, concentrations of pollutants in the water column, number of bird calls per unit time or unit area. These are level 3 quantitative data. They all work together. And finally, there's the special studies of methods of and hypothesis testing. So every sophisticated monitoring program has a research component to it. It can be about developing methods, how to interpret that, new statistical methods, or looking at cause and effect. So I'm not going to focus on that because I'm talking about monitoring and assessment, but we have to acknowledge that every really mature monitoring program has a research component to it. Now, level 1, 2, and 3 are not mutually exclusive from each other. If you want to go out and do a probabilistic or other random survey of condition using level 2 or level 3 methods, you have to have a map to know where you're going. That's the sample frame. So level 1 is almost always part of an answer. Now, level 2 may be or may not be. If somebody says, I just need to know the overall condition of this population of wetlands, a rapid assessment method is good for that. If somebody says, I need to know how many, you name it, species, clapper rails exist in this marsh, that's not level 2, that's level 3. Somebody could go out and count the clapper rails, right? But you can see how these things relate to each other. And by the way, level 3 data are necessary to calibrate level 2. If level 2 is measuring overall condition and overall condition and potential to provide certain services, you have to measure those services, relate them back to the rapid assessment method to make sure it's working. So these things are interrelated. Once you get that, then you have a sample design. In this framework, we promote probabilistic design because we're working at the landscape scale. Probabilistic means random, but not. Random, but you take into consideration the inclusion probabilities of your sample points. I won't go any further than that, except to say that if we're talking about wetlands, they're not all the same size. So if you just randomly drop points on the landscape to go measure something, the larger wetlands are more likely to have sample points in them because they're just larger. So weighting the sample points by the percent of the resource they represent is probabilistic because it includes the inclusion probabilities. So that's that. Targeted sampling, of course, is also important, but we're pushing probabilistic sampling because it allows you to say things about the resource as a whole, not just the data population. Then it gets into data management. There are regional data centers and BIOS, and those communicate with the California Environmental Data Exchange Network, or CEDN. That goes to analysis and interpretation. We make a big point of interpretation. A lot of times data are collected and nobody's been identified as to how they're going to interpret it. Remember, trying to go back to answering somebody's need for particular data to make a decision, then the data have to be interpreted with regard to that need. So knowing in the beginning who's going to interpret the information is really very important. Now, many people can interpret it. The idea is the data gets public. All kinds of interpretations happen in the data I collect, some of which I just can't believe. But still, there needs to be some identified body to interpret the data relative to the question that's being asked. Then you end up with a condition assessment that's formatted to answer the question. That goes into public reporting. There are many kinds of paper reports that go out to the programs and to the public. There's a thing called Eco-Atlas that we'll talk about in a minute. There's My Water Quality portals through the Water Quality Monitoring Council for the state. It's another way to deliver reports to the public. And finally, that goes up and answers the question. So this is the framework that we're all living with right now in this RAMP world. And I'm going to go through and populate this so you know that it's getting real. There are biological goals and objectives of HCPs and NCCPs, water quality standards, management, SOPs, et cetera. There's Aquatic Resource Inventory, or CARI, which is a classification system as well as a mapping SOP. There's a Riparian Zone Estimator tool, Delta Landscape Metrics. I'll go through these in just a minute so you see what they're like. California Rapid Assessment Method, proper functioning condition. There's SWAMP IEP, the regional RMPs for water quality, HCP, NCCP, the monitoring methods associated with those. There's a probabilistic sampling methodology called GRIT coming out of EPA that we employ a lot, both in the Bay Area and now increasingly in the Delta and other parts of the world. There are actual regional data centers at Southern California Coastal Water Research Project, or SQUIRP, down in LA, SFPI, where I work, and Moss Rennie Marine Laboratories. CEDN is a real thing, and Eco-Atlas is becoming a real thing. So we're moving through various parts of this framework now, causing it to come to fruition. And that's the last time I'll bore you with this kind of a diagram. Now we'll just go into some of the tools, except for the governance structure. So there's a thing called the California Wetland Monitoring Work Group, CWMW. And that is a work group of the California Water Quality Monitoring Council. John Marshak is here, who's executive director of that. So if we need to know more about it, go to John. Raise your hand, John, so people can see you. If you don't know John, you should. And they're federal programs, so that the CWMW is not just a bunch of state agencies, it's also federal agencies. It's federal and state. Within the CWMW, there are L1 through 3, level 1 through level 3 data type, and Eco-Atlas steering committees. Not all the committees have been established yet, but some have, and we're establishing others this year and next. And of course, each of those has technical advisory committees. And those committees are whomever we need that are the best people to advise the development of those tools, federal, state, NGO, private sector, and academia. That's the basic structure. Open rosters for those things. Anybody here wants to be a part of that? See John. Or me. Okay, here are the agencies taking part, a lot of them. Here's federal agencies, a lot of them. Other agencies and entities, I point out the Habitat Joint Ventures newly involved with the Wetland Monitoring Work Group. I'm beginning to use many of the tools you're going to see in just a minute. Okay, so there are many tools. I'm going to show only a few of them, Their purpose is to help develop and align water quality and habitat objectives for wetlands and riparian areas. They track and report compliance and effectiveness based on wetland abundance, diversity, and condition. There's that phrase again. And these are the tools I'm going to run through rather quickly. CARI, RipZET, I'm hoping you haven't heard these things before. Project Tracker, CRAM, you've heard about now. Probabilistic survey design, cumulative frequency distribution, project performance curves, GreenPlan-IT, it stands for IT. These are LID, locator and tracker tools, landscape profile tool, and eco-atlas. I'm going to go through a few slides for each one to give you a flavor of these, okay? Here, is this PowerPoint going to be available to people? Okay, that's good news. Yeah, you can, well, that's unfortunate, but you can stop taking notes and get a copy of this and make your own notes afterwards. Okay, CARI, California Aquatic Resource Inventory. Inventory of aquatic resource abundance and diversity. Why do we have this thing? We have the National Wetlands Inventory. Well, turns out NWI, the Fish and Wildlife Service, can't get any map done for a state before the map changes. And when they get something almost done, they get complaints about omissions and classification errors. Also, the classification system they use is not the things that people in this state talk about. We have different words for wetlands than the nation uses coming out of DC. So for reasons of classification, accuracy, and detail, a separate inventory was needed. Same with the National Hydrographic Data Set of USGS. Those things aren't wrong. It's just really hard to do something at the national level that'll work at the state level, or better yet, at the local level. So what you'd like is an inventory that can provide integration from federal to local operation. So you're actually informing land use, which, as you know, is a local government process. So this is a map of enough detail to inform local planning. And in fact, built into it is a process of local data stewardship where local agencies can fix the map when they see it's wrong. This stays alive from the bottom up. Statewide map of abundance and diversity intensifies as two federal maps, supports statewide stats and trends. It's the base map for some of the My Water Quality portals of the Water Quality Monitoring Council, and regional versions are possible. This is the Bay Area Aquatic Resource Inventory, the Bay Area version of CARI. There it is for the whole state. I'm zooming in now, and this is a little piece of the North Bay Area. And what you see in the center there is BAARI, and the other part is NHD NWI. So if you're modeling sediment delivery, if you're modeling hydrology for salmon, if you're just a local agency and someone comes in and says, I'm going to develop the following 10,000 acres, unless you have BAARI, you don't even know where the aquatic resources are. You don't have any official map of what the distribution and abundance and diversity of those resources are. Here's the Tahoe version of CARI. Here's NHD NWI. Here's TARI. It corrects classification errors. It greatly corrects omissions. It includes more aquatic resources than are otherwise visible, and if you can't see them, you can't protect them. Here's the Delta Aquatic Resource Inventory. Here's NHD and NWI, and here's DARI. These are corrected classifications. This is habitat detail, and these are corrected omissions. Unfortunately, I'll just tell you, only about 25% of the delta has been mapped so far. So what we see now is that the map for the tidal marshes are really pretty good. They miss a lot of channel detail that translates into fish habitat for some fish species, but most of the aquatic resources behind the levees are not mapped. So as restoration moves forward, and agencies like the Corps of Engineers and EPA and Fish and Wildlife and both state and federal need to look at mitigation ratios, they need to see what are the wetlands on the existing properties that might be converted to tidal marsh. Without a map of those, you really can't talk about them very well. RipZET is the Riparian Zone Estimator tool. So that was CARI. Now let's say you've got CARI, some version of it. Now you can operate on top of it with a lot of different kinds of GIS. One of them is RipZET. It visualizes the National Research Council's riparian definition. This is not trees along the creek, folks. The national definition says every surface water has riparian all the way around it. What varies is the width. Doesn't matter if it's pavement. In theory, it has some riparian. It could be very narrow if it's just pavement, but the width depends upon the function, topography, land use, vegetation. It's a variable width depending upon what you want the riparian zone to do for you, basically. This tool runs on top of CARI to estimate those widths based upon the functions you dial in. What I'm showing here is a basic vegetation function for a loftiness input and shading and so forth of small headward channels by vegetation. And the dark green areas are where the vegetation is very tall and provides that function. The areas without green is where the vegetation isn't tall enough to provide those functions. So you get a different picture depending upon what functions you zero in on. Other modules are being developed even as we speak. There are modules around each of these functions, for example. So you can take RipZET, you can run one function, run another function, look at them together. It gives you a much broader picture of what riparian means. You can imagine that implementing that concept is an awful lot of discussion. When you have people that have been trained and have grown up with the idea that riparian is a simple thing of trees along the creek, and you give them a whole different definition, then they have to internalize that, and that's a process. It takes some time. So once you get to RipZET, though, you can do things like this. Where on the y-axis, we have riparian width in meters, from 1 meter wide to more than 100 meters wide. When you have really wide riparian, you support essentially all of the functions of riparian. And when you have something very narrow, there's almost no function to the riparian. This happens to be a survey in the Napa watershed, and this is what they have right now. Now, historically, they had a lot more that was a lot wider. So we could show the historical picture as well. This gives you a sense of the distribution of riparian functional width at the watershed scale. And you can see how it would cause watershed planners across agencies to wonder where they should put the riparian. Maybe we need some more riparian back of different widths, depending upon the functions that they're keyed into. Here's another tool, Project Tracker. The idea here is just to enable people to see each other in terms of the projects that they're doing. It's operational in the Bay Area. The prospects are it's going to be operational in the South Coast, the Central Coast, and in Tahoe this year. They're already piloting this in those regions. So my guess is it's going to show up with a lot more data here this calendar year. So the maps are projects provided through permits. The best scenario we have right now is that you can make mapping projects a condition of the permit you get for that project. So Online 401, which is a new tool coming along to implement Project Tracker, says to get a 401 certification, you got to give me a map of your project. You have to classify the habitat types according to CARI SOP. And so we build the CARI picture of past and present, and we can look at net change as a result of projects. It's searchable. So here's an example. This is the Montezuma project that you may not have heard about, but you will this year because it's right at the western edge of the Delta. It's kind of under the radar. It's 2,000 acres of tidal marsh restoration with the first breach later on this year. And they've been using this for 10 years to track their products. Here's a map of all the projects currently in Wetland Tracker for just the Bay Area. I could show the whole state, but most of the projects in the database are from the Bay Area. This is the Montezuma project in green. We're zooming in there for you. You can search by project, you can search by location. There's a lot of searchability, panning functions in this tool, as there are in most GIS-based online tools. What's interesting, though, is when you go in there and look at the basic information about the tools, you can also upload new information. People upload reports, they upload URLs to chat rooms, they upload videos, they upload photographs, they upload raw data, they upload all kinds of stuff. So here's a case where one major project is realized, and the consultants working on the project have realized this makes the 12th hour a little longer for them. They don't need to send a paper report to somebody. They can just tell somebody by email the reports on EcoAtlas in the Project Tracker software. So really, each project becomes a mailbox now for communication between agencies and between them and the public. CRAM you've heard about, Rapid Assessment Method for Wetland Streams and Riparian Areas. It measures the overall potential or capacity of a wetland area to support a broad level of its intrinsic functions at a high level, a broad suite of those functions at a high level. There are separate modules for each of the CARI wetland classes. Classification system for CARI identifies the kinds of wetlands that this state likes to talk about. And for each of those, there's a module of CRAM. There's a training program. There are trainings that happen every year. I think we're up to something like 800 trainees and 4,000 CRAM assessments across the state at this point, the statewide database. Okay, now I'm going to cover these three at the same time using CRAM as an example. Probabilistic survey design, cumulative distribution function, project performance curves. What I want you to realize, each of these things I'm stepping through, this is the tool set for RAM. And I want you to leave this realizing, wow, they're actually doing these things. Every one of these tools has gotten to where it is through pilot projects with real people at real places, real sensitivities, real data gaps, real stakeholders, and the rest of it. So you're seeing the aggregate success or progress on these tools within the RAMP framework. So you can do a probabilistic survey of ambient or baseline condition at any scale. This happens to be a watershed. This is the Santa Rosa Plain up by Santa Rosa in Healdsburg, the upper part, one tributary of the Russian River. You can also do this for projects. The same process that pertains to probabilistic surveys for large areas can pertain to projects. When you get done with that, you can develop these cumulative distribution functions. On the left is percent of total stream length. So I've taken one data set, one wetland class, in this case streams. Streams are wetlands based upon the new wetland definition for the state. A little confusing, but scientifically valid. So I'm going to show you some results from the stream survey in a watershed, and the CRAM scores are across the bottom. So because the probabilistic survey, you can plot the data as a percent of total stream length, not a percent of the population of data, but a percent of the entire resource, because the inclusion probabilities are included in the probabilistic design. So you're no longer just talking about the population of the sample, you're talking about the resource within the sample frame. This shows you that the 50th percentile scores about 73. You can also then say, well, that's what we have now, that's not what we need. For a variety of reasons, you can imagine you need more wetlands that score higher for filtration of sediments, for support of endangered species or other wildlife. You can imagine the reasons at a watershed scale for wishing you had more wetlands of more kinds in different places. And that's called a future profile. So we have an existing profile, and we have a future profile built through, I would imagine, a lot of years or at least months of communication with stakeholders. And then you can put your projects on there. And you go, look at that. A lot of our projects are below the median level. That's not good. That would suggest the restoration mitigation projects are going to pull the whole profile down. What's wrong with these projects? Then you go to a performance curve that tells you what is the likelihood that those projects over time are going to get improved scores. The problem may not be with the projects, just that they're very young. They haven't gotten to where they're going to get to yet. Use performance curves, which measure the expected progress in the performance of a project over time. They don't start out perfect, right? They have to mature as ecosystems. And you can use that information to project when you think those projects are going to be in the future. So without talking about, time explicitly, you can say, well, based upon the performance curve, we think the projects are going to do this. So these tools together begin to provide you a sense of landscape scenario planning. What do we have now? What do we think we need in terms of wetlands or riparian or other surface waters? How are our projects doing? How do we expect them to improve? And if they don't show this kind of trajectory, what could we do about designing them in the future so they are on that performance curve and they will achieve those objectives in the future? GreenPlan-IT, or IT, it stands for IT, is a way of locating or citing landscape, LID projects. It involves hydrological modeling and an optimization tool. So it uses local and regional data, transportation, stormwater, et cetera, to locate where LID would be useful. That turns out to be an opportunity map. It incorporates cost factors as well as hydrological or ecological factors. And then it generates an optimal watershed watershed-based green plan for the watershed. So this is intended for urban watersheds. What can we do to retrofit ecological service back in by controlling hydrology and controlling pollutant loading through LID? Here's an example output from the south part of San Francisco Bay. There's an opportunity map with hydrological models, an optimization tool, and finally a watershed green map as a GIS output to the local agency. The local agency then takes that and says, I know what LID to put where and how much of it I need to achieve a certain reduction in peak flow in the hydrograph so I don't get into hydromodification of the channel, or a reduction in pollutant loading so that I meet water quality standards downstream. So this is a particular watershed-based tool designed for urbanized areas. Landscape profile tool may be the most important of the tools being developed right now because it integrates across the others that you've seen. It measures the abundance and diversity of aquatic resources and other information, summarizes that for user-defined watersheds or other landscape areas. So if you've ever heard the need for a watershed map, this makes watershed mapping really easy. You can either click on a blue line, on a creek line, on the CARI map, and it'll draw the watershed for you, or you can go in and draw it for yourself. Or you can upload any shapefile or a KML file that you want to indicate the area under which you want to summarize information. It generates custom maps, graphs, and tables as automated PDF that can be downloaded. So you get an actual PDF report of the watershed profile that you can use in your own reports or share with friends. The current focus is on 401 and waste discharge requirements, but program-specific versions are possible for stormwater, TMDL, lake and streamlet alteration permits, timber harvest plans, HCP, NCCP, et cetera. There's a real desire now by the Water Quality Monitoring Council, or I should say the Wetland Monitoring Work Group, to reach out to these programs and ask the question, what data would you want in the landscape profiles that actually it's actually useful to you? It's not one profile for everybody. It's a tool that can be adapted with different data inputs to be particularly customized for individual programs. So, for example, right now, if you go on your computer and you just type in EcoAtlas and you hit the thing called Tools, Landscape Profile pops up as one of the tools sitting in EcoAtlas, and you can decide, well, I want to auto-delineate a watershed, and when you do that, you choose that, and you click on a blue line, the signal goes to USGS in Golden, Colorado, and it draws the watershed for you and then sends it back. You don't know that, but the way these systems are working now are through web services. EcoAtlas is not a database. All these data aren't sitting in there. It takes your request and goes out to wherever the data are and brings the data back. But it doesn't leave it there. It just operates between you and that remote database in a seamless kind of way. Or you can draw your own area of interest. In this case, I've done that. These are screenshots. This is an area I drew. If you click on any one of those circles, other circles appear between the two you see, so you can modify and edit this anytime you want to. You can save it, or you can start a new one. You can stop now and come back to it. It's kind of built on the TurboTax idea. You know, I can't do this right now, but it remembers how far you got, so when you come back to it, you can pick it up from there. Very user-friendly, very, very fast. And what it does then is it summarizes all the information it can that you've identified or that are accessible to it underneath that polygon and generates a report. So in this case, for example, it's got a pie chart of the different kinds of wetlands and other resources, aquatic resources, underneath that polygon. This is really just seconds away and gives you that. It can also, at this point, summarize this kind of information. Historical aquatic resources, if the historical ecology has been done, all the restoration projects and mitigation projects underneath that polygon that are in the database, the condition based upon rapid assessment method, population size. A lot of people use it to find out. They say, well, I'm just a local watershed group, and I've got this outreach program, and I'm not sure what languages are even spoken in my watershed. They use this tool, and it tells them how many home languages are being spoken by which people in the watershed. So that's, and of course, gives you demographics, too. It summarizes the natural diversity database for the state, and it gives you developed land cover by the National Land Cover Data Set of USGS. So again, this is more than proof of concept. But if you're in a program in stormwater, you might say, that's not what I need. I need something else. And that's what we're looking for at this point. in this junction, the development of this tool, we're looking for programs that will say, this doesn't work for me, but if you give me these data, or we access these data, this will work for me, and I need this. So we're really shopping this tool around right now, that is the Water Quality Monitoring Council is, to find out what other programs besides 401 might be interested in this kind of a tool. Finally, there's EcoAtlas. EcoAtlas is not a database, it just aggregates data. This is a system that goes out and finds the data you're looking for and brings it back in. In the context of that RAMP framework, you're trying to answer somebody's question. You need level 2 data, you need level 3 data, you need level 1 data. This is the system that goes out and grabs that and aggregates it in the landscape profile or other tool. Project Tracker and Landscape Profile tool reside in EcoAtlas. It's the only tools that are sitting inside EcoAtlas right now. The databases are not there, but the tools are. So if you go online to use those tools, you go here first, and then you find the tools, and they go out and get the data and bring it back for you. And it's currently the delivery system behind multiple My Water Quality portals. Not all of them, but most of them. Okay, I'm going to finish with this. This is the strategic goal. This is where everybody thinks this is why we're doing this, especially in the context of climate change. Support landscape scenario planning. What if? Support playing God in watersheds, basically. Recognizing everything is managed to some extent, the question becomes, what levels of what target resources do we need to protect or achieve? It's to support answering that question. How much of what do we need where to survive? Coordinate efforts across public policies and programs and projects to achieve that ideal, and maximize the efficiency of coordinated efforts to routinely track and report progress. That's the idea. To help the agencies work together to say, what do we need this watershed, this landscape to do for us? Now, with BDCP, you get one set of answers. To Fish and Wildlife, hopefully a very similar set of answers, but maybe not exactly the same. So landscape scenario planning lets people look at the differences between their objectives, see what's common, and begin identifying different places to put the services in the watershed, whether it's LID or wetlands or riparian area or streams, what the consequences of those are based upon theory, what monitoring is necessary to track progress relative to those expectations and assumptions, and report back to the public. That makes sense? That's the upshot of this. That's a lot for a short period of time. Hopefully you get some sense of progress and status. All right, thank you.
So we have time for some questions if you have any. And folks on WebEx, if you want to type your questions into the chat bar, we'll try to get them asked for you.
So maybe I'm just hung up on the terminology a little bit, but it was a little unclear about how open water areas are classified in this system. I'm thinking something like Sassoon Bay. Do you classify the whole bay as a wetland? It was a little vague to me. It's kind of clear when you're talking about streams and small streams, but when you get into the major rivers and bays, it's a little different.
Yeah, the open water areas of that size, like major bays, are not regarded as wetlands. They're regarded as open water areas. This is primarily focusing on the wetlands, both vegetated and non-vegetated, at the margins of those systems. But CARI, the Aquatic Resource Inventory, maps all of those areas, both the open water areas, at least the surfaces of them, and then the wetland areas along their margins as well.
Okay, is Montezuma Slough part of a wetland or an open water area?
It's both. It has an open water area and has wetlands along the margins of it. And CARI distinguishes between those two things. So you get, when you map Montezuma Slough or you look at Montezuma Slough, you would see in the map not only the open water area as one polygon, but you would also see the wetlands along the edge as separate polygons, depending on how many kinds of wetlands there are.
Okay.
Yeah. And then, just to further complicate things, but because you're asking, if you were to follow a tributary up into a tidal marsh, there's a point at which that tributary is dewatered at low tide, and from there upstream, it becomes a wetland. Okay? And those definitions are all included in the SOP for CARI. is why it's so long. Thank you for that question. Does that answer it, by the way, or? Okay.
Anyone else?
That's a lot, you guys. I know you have questions.
Reiner has a question.
Like, how do I get out of here?
Where do we get the slides?
On the Delta Science Program.
The question was, where do I get the slides? And Garrett says they'll be posted on the Delta Stewardship Council website. Yeah.
John, my question relates to something that's particularly of importance here in the Delta and in the tidally influenced reaches of all the, channels and marshes. When you showed your performance curves, that some of them were pretty widely scattered, scatter plots. Have you assembled enough of the CRAM data for tidal wetlands over time to see what those trend lines or performance curves actually look in reality?
Yes, and there's a report just released to EPA that I can send to you, and you can put it on your website. When you do a performance curve, that is when you're saying what is the performance of a project over time, and you don't have any projects that you've been tracking for 50 years, you have to substitute space for time. You have to look for projects of different age, assess them once, and assume that together in aggregate, those projects at different age begin to resemble what one project would do over time. So we have assembled, and when you do that, and you're looking at projects of different age, and many times the reports in those projects don't exist anymore. The people who designed them have retired or moved away. So it's a real detective effort to get something like time zero. When did the project start? So going through all of that, and then assembling the data, we have over 300 cases now for projects of tidal marshland in California. And the curve I showed was a preliminary curve. It's a little tighter now. But it does, in fact, suggest that based upon the current and past approaches to tidal marsh design, for the overall index of CRAM, assuming that CRAM actually does measure the potential of these sites to provide the functions we want, that's a big assumption, it suggests that it will take between 45 and 55 years for those projects to achieve reference condition, which is about pretty close to the max amount of time we have left before climate change and sea level rise switches that performance curve, and we have to choose new reference conditions lower in the tidal frame. If that makes any sense to you. So the big news from that study is that, well, we probably have enough sediment and sea level rise will be slow enough over the next 50 years. The projects we're doing right now are likely to approach the reference condition based upon performance curves, especially if we design them the way we've started to, which is better than we used to. But projects that start in 10 years, they won't achieve those reference conditions. We'll probably have to identify new reference conditions, which are younger marsh at lower elevation, and the reference conditions we have now, which are ancient marsh at high elevation. Does that make sense?
Yeah.
Okay.
Thanks.
I can send you that report.
Hi, I get to ask the new guy questions. So with this growing consensus that you showed us in policy emphasizing watershed scale management, is there any legislative ongoing attempt to allow the Delta Stewardship Council to manage an actual watershed of the Delta instead of the legal Delta?
I can't answer that. I can tell you before Reiner starts talking. He's shaking his head. One of the questions that this raises is if we go to the watershed scale, and part of this is driven by climate change, the idea being that it takes forever to get a project permitted, to develop rather slowly, and if we just keep doing it project by project by project at the footprint of most projects as we define them now, we're going to get so far behind climate change that we can't achieve our goals before our goals are no longer even valid. So we need to move permitting to the watershed scale. Who gets the permit? That's the big question right now, is who gets the permit? Is it a watershed council, local agencies, or in your case, is it a consortium of federal and state agencies that gets a permit? Some of this is already happening through regional general permits and stormwater permits at the regional watershed scale. There isn't precedent. We're talking about a permit that would cut across a lot of policy and programs, and no one's quite figured that out yet, as far as I know. Doesn't mean we shouldn't do it. It's just going to be tough.
I'm going to let Sam have the last word.
So right now in the Delta, probably ag land is one of the most valuable kind of wetland areas right now. I mean, there's more geese and migratory birds out there on ag lands than anywhere else. How are those dealt with in this scheme?
It's being worked out. I mean, one of the reasons that the Delta version of CARI hasn't been produced for the whole Delta, it's been produced for the footprint of the conveyance systems, the alternative conveyance routes for the tubes, and the DWR and EPA and the Sacramento District of the Corps agreed to a mapping process, CARI, to get those. Now that they have the map, the question becomes, is it jurisdictional? And the answer is no. At least CARI says it's not a jurisdictional map. This does not replace jurisdictional delineation. So how many delineations do we have to do to calibrate CARI relative to a JD because of those resources? So now that people are beginning to see how many of those kinds of wetlands exist in those diked areas on private or public land, the question is, how accurate does the map have to be to translate it into mitigation ratios? So that's being discussed. That's where it is right now. Those resources are well appreciated, but until you get a map like CARI, you don't really know what their extent is. And so getting that first map caused people to sit back and go, wow, now what do we do? And they're working on that. But there has to be some determination of to what extent are these farmed wetlands, the legal term farmed wetlands, to what extent are they natural wetlands? Those questions are being worked on. I'll just say that one of the best things about CARI is that it causes those decisions, those debates to happen that need to happen. You get a map in front of you, there's just not much to talk about.
Okay, I think we're going to end it there. So why don't you guys join me in thanking Josh for his time and efforts.
Thank you all.